Okay, welcome to this video on fuel test. On this video, I'll show you the lab, what you'll be doing on your lab session. So the objective of this video is to tell you about the lab in advance, explain to you the principles, the theory, the procedures, and then how to write the reports and what to discuss in your lab report. So in the end, finally the benefit will be used, that is better learning and also to get good grades. So this is the aim of this video. So this video is on fuel test. So we use fuels every day, like this biomass fuel we use. This is wood pellets. We use biomass in the biomass boilers, like this thing. And then we use petrol, this petrol in car and in other systems, thermodynamic systems. We use natural gas for central heating. We use diesel in diesel cars. So we use various types of fuels in every day. We use solid fuels, we use gaseous fuels, we use liquid fuels. So as an engineer, we need to know about the quality of these fuels. So how we measure the quality? We measure some properties, some physical properties, some chemical properties of fuels. So in terms of physical properties, we measure density, we measure energy value of the fuel, we measure viscosity, we measure flash point of the fuels, and then we see the moisture content if it is solid fuel. We see the Ceton number, octane number. These are some physical properties of fuels, and there are some other chemical properties of the fuels as well, which are we would like to see what are the carbon content, oxygen content, hydrogen content in the fuel, and then how much ash it will generate due to the burning, how much carbon will be formed in the engine after the combustion process. There are different sort of chemical processes as well. So by doing the physical analysis, properties, and also chemical analysis, we are able to assess the properties of the fuel, whether it's a good fuel or a bad fuel for combustion, for energy generation. So in terms of as a mechanical engineer, we are very much interested about the energy, what energy we put in and what energy we get out from the system, thermodynamic system. So this is very important, and you all know that the energy in and energy out, if we know both things, we can assess the performance, i.e. the efficiency of the machine, of the thermodynamic system. So the heating value or energy content of the fuel is very important property of the fuel. So on this lab, you will be measuring the heating value of liquid fuel and solid fuel. So here you will select one liquid fuel, either petrol or diesel or biodiesel, and another one solid fuel, which is normally we select biomass fuel. So what is the principle behind the measurement of heating value? Here in our lab we have got one calorimeter, which is a PAR 6100 calorimeter. This is semi-automated type calorimeter. We use this calorimeter to measure the heating value of the fuels. So what is the heating value? How we define the heating value? So heating value of any fuel is the energy generated due to the combustion of that fuel. So normally it is expressed in megajoules per kilogram in SI system. So if we burn 1 kilogram of fuel in an enclosed container, the energy liberated due to the combustion of that 1 kilogram of fuel is known as heating value or calorific value of the fuel. So how we measure this calorific value, how the machine works, I'll just briefly explain to you first, and then I will show you the step by step and the procedures. So what we do, we take first this, we take some sample, fuel sample, into this small container known as crucible. We take little bit of sample, and then we measure the weight of that sample, and then after that, this is the main vessel where the combustion takes place. So if we open that vessel, we can see here, so we take the sample in this crucible and then put this sample in here in this into this loop, electrodes loop, and then we take a fuse wire, 1 cord length, which is about 10 centimeter, and then connect this fuse wire in between 2 electrodes here. Yeah. And then after connecting this fuse wire, we put this sample inside this container, and then we close this cap, we close this big screw cap, and then after closing this the screw, big screw, we put this vessel in this container, in this big bucket here, and there is water in this bucket, you can see, and then we put the whole vessel into this bucket, at the center of this bucket, and after some time the combustion takes place here inside the bucket, the fuel burns, and the energy liberated due to the burning of this fuel goes into the water. When the water, the temperature of the water increases, so there is a delta T of, so from that, so the software, the machine, there is a software inside the machine. That software calculates the energy generated due to the combustion of the fuel, which is due to by measuring the delta T of the water, the software calculates the energy liberated, which is the calorific value of the fuel sample. So now I'll show you in details. So this is the principle, basic principle. So what I'll do now, I'll show you step-by-step procedures. So let's take a crucible here, and then we take this crucible to this balance here, this precision balance. Okay. Put this crucible here, and then tear this so that we can get the net weight of the sample. Take the crucible out from the balance. Yeah. And then we take a fuel sample. Here we are taking one sample of fuel, which is a type of biomass. Here, this is the sample. We are putting here this sample, and taking this sample with crucible to the balance again. Okay. And then here we can see the net weight, which is 1.059. So we need to write this weight, keep a record of this weight, 1.059 gram. So take the sample out of the balance, and then put this sample here in between the electrodes in the loop. Just gently push it down. Yeah, don't push hard, gently. Okay. And then take one card length fuse wire from here using the plier provided. And then connect this fuse wire in between electrodes. So you have to connect the fuse wire in between the electrodes in such a way that the fuse wire does not touch the sample. Just pressing the hole. Okay, so there are two tiny holes on both electrodes, and then connect this fuse wire in such a way that it does not either touching the sample, it does not touch the sample or the crucible. Make a U-loop like this. Like this. So the fuse wire is not touching the sample or the crucible. This is important. And then put this head, place this head into this container slowly and gently, and then make sure this gas release valve, small screw, gas release valve is open, and then push this down gently. Okay, and then close this vessel using the big screw. Don't use any spanner, using just hand tight, but make sure it's properly tight. Okay. and then after that close this gas release valve. So first big screw and then small one. Okay, and then we'll take this vessel next to the machine now. And then let's switch on the machine. So you can see the machine now. This is a stirrer, steering, and this is thermocouple. It measures the temperature, this one, and stirrer stirs the water to maintain the equilibrium temperature. So I've just switched on the machine. Machine is now warming up, and you can see here in this machine inside. So the bucket goes here inside, bucket with water, and there's a screen here. So it's just starting. This is the software starting now, and this is the oxygen cylinder here. We need oxygen for combustion. So let's connect this oxygen hose here into this vessel. So just push down, okay, and then if you see this screen here, calorimeter operation here, so just click calorimeter operation, and then there is a button O2 fill, which means oxygen fill. So let's press O2 fill. So oxygen now going from the big cylinder to this vessel, calorimeter vessel. So when this oxygen filling is finished, the software will tell us that oxygen filling is finished. Okay, so let's wait for the oxygen filling to finish. So it's nearly done. Okay, so which means oxygen filling is done. So let's disconnect this now, and then after that, preparation of the bucket. So in this bucket we take 2 kilograms of water. So I have taken already the 2 kilograms of water. You can see the water here inside the bucket. So 2 kilograms of water. So this bucket with 2 kilograms of water goes inside here into this machine, but we have to check the slot at the bottom. So make sure you're checking the slots, and then I'm just placing this bucket inside according to the slots position, and then using this fork here, lifting handle, we can lift this whole vessel and then put this vessel into the bucket inside. So while we lower this bucket, we can connect these 2 wires to wires the electrodes, and then gradually place the vessel at the center of the bucket. Okay, and then carefully